Alright, you see that sort of large W-shaped constellation right there, that's Cassiopeia, and that Cassiopeia gives off a whole lot of radio signals. I actually listen to that a lot. It's a remnant of a supernova since the birth of philosophy. We've never stopped wondering about the answer to the question, are we alone? Ancient Greek philosopher Epicurus considered the universe to be the result of jolting of atoms and regarded it as highly likely that there were other worlds out there and that they were inhabited. But since the time of ancients, did we make any progress in regards to answering this deep cathartic question? As NASA has explored our solar system and beyond, it has developed increasingly sophisticated tools to address our endless curiosity for the possibility of life existing elsewhere in the cosmos. With our solar system, NASA's missions have searched for signs of both ancient and current life, especially on Mars and Jupiter's moon Europa. Beyond our solar system, missions such as Kepler are revealing thousands of planets orbiting other stars, fueling our imaginations further with bewilderment, wondering if there are other civilizations out there, perhaps asking the same question, are we alone? The explosion of knowledge in planets orbiting other stars called exoplanets and the results of decades of research on signatures of life, what scientists call biosignatures, have encouraged NASA to address in a scientifically rigorous way whether life on Earth is unique. Beyond searching for evidence of microbial life, NASA now is exploring ways to search for life advanced enough to create technology. Unfortunately, so far we only have one data point in regards to the existence of life in the universe here on Earth, but that shouldn't suggest that it can't tell us anything about the possibility of life existing elsewhere. The prevalence of life in the galaxy, if you can quantify that somehow, I don't know how to quantify it just yet, but imagine that's a quantifiable entity, the prevalence of life that we presume to be out there. The stock in the prevalence of life has gone up. For me, the best argument for upping that stock value is the following. When you took biology class and you learned the age of the Earth 4.5 billion years ago, and then you look at the earliest evidence for life, fossil evidence of life on Earth, then you get about 3.5 billion years. Subtract those two numbers, get the difference between those two numbers, and that's the time clock from beginning to the first evidence for life. So that was about 1 billion years out of the 4.5 billion years that Earth has been here. So that's pretty quick. It happened in like the first 20 of the life of the planet. Now we have found fossil evidence of life farther back in time than 3.5 billion years. It now goes back to 3.8. There's some evidence it might even reach 3.9, so we have shrunk in the time available for life to have formed on this Earth. That makes it more likely if the faster life kicks in from a pool of just random chemical, not random. They're the chemicals of the universe. The faster that happens, the more confidence I have that life is something that would happen just given the right soup and soup starter. Now we then learned when computers got good, better than they once were, that the early solar system didn't just simply make the sun and the planets. It was debris all scattered interplanetary and interplanetary space, and that debris slowly got vacuumed up by the gravity of the respective planets. That would not have been a pleasant occasion on the surface of those planets, because to vacuum it up simply means you're getting slammed by the kind of asteroid that took out the dinosaurs, except you're getting that monthly, and you can calculate what the temperature of Earth's surface would have been, and it would have been higher than what would allow complex molecules to form, because at high temperatures you break apart molecules. What our computer models show is that this period of bombardment, period of heavy bombardment, is the official phrasing, lasted 600 million years, so it's not fair to start the life clock at 4.5 billion years ago, because life had no chance of forming when the surface of the Earth is molten. Wait for things to cool down. When there's a chance that carbon can run its magic, then you start the clock. Now you're going from 4 billion years ago into 3.8 billion, and you have pinched down to 200 million years, down from 1 billion years that was imagined just a generation ago. And that is further evidence that practically the earliest life could have formed. It did so. Just because we find it hard to do in the laboratory doesn't mean nature has found it hard to do as well. And the idea that it's hard for nature to do because we can't figure out how to do it yet, that itself is an inexcusable expression of human ego, while evidence for the existence of alien life would be undoubtedly amongst the biggest scientific discoveries of all time. There is one discovery that would top that evidence for intelligent alien life. In 1961, American astronomer and astrophysicist Frank Drake proposed a probabilistic argument used to estimate the number of active communicative Extraterrestrial civilizations in the Milky Way galaxy. More than half a century has passed since Drake stimulated scientific dialogue on the search for extraterrestrial intelligence, but now we have more insights to some of the factors of the Drake equation in a paper published in Astrobiology. Adam Frank, professor of physics and astronomy at the University of Rochester and co-author of the paper, said the question of whether advanced civilizations exist elsewhere in the universe has always been vexed with three large uncertainties in the Drake equation we've known for a long time. Approximately how many stars exist. We didn't know how many of those stars had planets that could potentially harbor life, how often life might evolve and lead to intelligent beings, and how long any civilizations might last before becoming extinct. By applying the new exoplanet data to the universe's 2 × 10⁻22 power stars, human civilization is likely to be unique in the cosmos only if the odds of a civilization developing on a capital planet are less than about 1 in 10 billion trillion. 1 in 10 billion trillion is incredibly small, says Frank. To me, this implies that other intelligent technology-producing species very likely have evolved before us. It may be that intelligence is rare in the cosmos, intelligence as we have defined it, because if you look at the fossil record, look at the portfolio of life that has lived and thrived on Earth, there are a lot of features of life that many different species have in common. For example, locomotion is a pretty common talent. In fact, we have creatures on Earth with no arms and no legs, and they still manage to move. We call them snakes. So locomotion, they figured out how to move even though they don't have arms and legs. But what we have is evidence of features in life that apparently are really good for survival. The capacity to receive information at a distance, smell, hearing, sight is a very common feature in animals. In fact, there are certain expressions of sight that happen independently of each other. That's how valuable this was as a tool for survival. The fly eye has nothing whatever in common with the vertebrate eye itself, having nothing whatever in common with the octopus eye, yet they are all eyes and they all see. Let's look at intelligence. Intelligence, as we have defined it, has shown up nowhere in the fossil record, which tells me that intelligence can't be all that important for survival. Otherwise, it would have been there in the fossil records multiple times throughout life, but it's not. In fact, you can continue this to its extreme and say it may be that intelligence is just the right thing to have to render yourself extinct. In the summer of 1950, Italian-American physicist Enrico Fermi, while walking to his lunch with fellow physicists, was having a casual conversation about recent UFO reports and the possibility of faster-than-light travel. Allegedly, Fermi suddenly during lunch said, "But where is everybody?" This later became known as the Fermi problem or paradox, which is the apparent contradiction between the lack of evidence for extraterrestrial life and the high estimate probability for their existence. So, what could possibly explain this semblant paradox? Whatever is preventing non-living matter from undergoing abiogenesis in time to expanding lasting life as measured by the Kardashev scale, in the context of the Fermi paradox, is known as the Great Filter. The failure to find any extraterrestrial civilizations in the observable universe implies the possibility something is wrong with one or more of the arguments from various scientific disciplines that the appearance of advanced intelligent life is probable. This observation is conceptualized in terms of a great filter which acts to reduce the great number of sites where intelligent life may arise to the tiny number of intelligent species with advanced civilizations actually observed. Economist Robin Hanson described a list of 9 steps in an evolutionary path that results in the colonization of the observable universe: the right star system, reproductive molecules, simple single-cell life, complex single-cell life, sexual reproduction, multi-cell life, tool using animals with intelligence, a civilization advancing towards the potential for a colonization explosion, and a colonization explosion according to the Great Filter hypothesis. At least one of these steps must be improbable. If it is not an early step, then the implication is that the improbable step lies in our future, and our prospects of reaching step 9 of interstellar colonization are still bleak. If the past steps are likely, then many civilizations would have developed to the current level of the human species. However, none appear to have made it to step 9, or the Milky Way would be full of colonies. So perhaps step 9 is the unlikely one, and the only things that appear to likely keep us from step 9 is some sort of catastrophe via self-annihilation. Hansen's list, although incomplete, provides solace to the seeming paradox of Fermi in an attempt to answer the question, are we alone in the universe? A growing number of people believe we've already answered this question due to the recent UFO reports over the last few years. However, eyewitness testimony and ambiguous video footage does not qualify as extraordinary evidence to definitively answer this age-old question, but to be respectful to the people who believe we've been visited by extraterrestrial crafts. We will dedicate a whole video to this topic. Thanks for watching. Did you like this video? Then show your support by subscribing and ringing the bell to never miss videos like this. Music you.